Hey, this is Ray, and I'm going to show you my method for working out absolute value inequalities, especially if there is more than one absolute value in the equation. So let's say you have this here, x minus absolute value of x minus 1 minus absolute value of x minus x plus 2 is less than or equal to absolute value of x plus 1. So we have a minus sign in here, and most people don't like to deal with that. So we can just move it over and make everything positive. So our new equation looks like this. Plus 2. There. Okay, so now on both sides you have two functions, and on a graph they're going to look like any other curve. But you're going to have to find the point of intersection of these curves if you're going to find out, when one of them is greater than the other or stuff like that. So let's just say that we have two curves here, and then we have one of them here, one of them is less than this one, and here it's greater. So you have to find the point of intersection in between those two, so that you can check any values greater than it or less than it. To do that, we have to do some fumbling with the absolute values. So we're going to start doing some cases here. We have your original equation. Let's try working it out with keeping all the cases positive. Notice we have an equal sign here because we're just trying to find a point of intersection. So no inequalities here, doesn't matter right now. So we have x minus 1 equals x plus 1 plus x plus 2. When we solve for that, we get negative 4 equals x, and you can check that on your own. That would be the first case. Now we have to plug negative 4 back into your original inequality to see if it makes the two sides equal. So when we plug negative 4 back into this inequality, we actually get 5 equals 5. And you can check that on your own too. But yeah, so this is one of the points of intersection, but there might be more. So we're going to check another case, and this time we're going to make one of these negative and keep everything else positive. So let's try making x plus 2 negative. So we have here x minus 1 equals x plus 1 minus x plus 2. And we're going to solve for this here as well. When we do this, you get x equals 0. You can check that on your own. But when we plug x equals 0 into your original inequality, you get 1 is less than or equal to 3. This is a true statement, but it doesn't get what we want yet. So let's try a third case. Let's try making x plus 1 negative. So we have here x minus 1 equals negative x plus 1, and then we're going to keep this one positive, plus x plus 2. When you solve for that, you get x equals 2. When you plug x equals 2 back into this inequality, you actually get that 1 is less than or equal to 7. While this is still true, it still doesn't get what we want because we want the point of intersection for when these two equal each other. So we have one more last case, and that's making x minus 1 negative. So let's try that. Negative x minus 1 equal to x plus 1, that's positive, plus x plus 2, that's positive. When you solve for that, you get x is equal to negative 2/3. Plugging it back into the inequality, you're going to get 5/3 equals 5/3. All these you can check on your own. So we know that for x equals negative 2/3 and x equals negative 4, these two inequalities are actually equal. So that means that somewhere on this graph, we have a curve here, and maybe a curve like this. And that's just saying that these two are the places where they intersect. And then in this region, one of the curves is greater than the other, And then outside this region, this curve is greater than this one. Visually, you can check it on a calculator, but if you don't have a calculator with you, we're going to check these 2 points of intersections on a number line. So we're going to draw our number line right here. We have -4 right here and -2/3. Those are the values that we wanted, the critical values that we wanted to solve for. When you use these two values, the equations are equal. Now, we're going to try some values in between these 2 points of intersection and outside these 2. That way we can solve for every case and we can solve for which curve is greater than the other. Now we want the second curve to be greater than the first. So if it turns out that the right side is greater than the left side, then we will know and we will put a check. So let's try, say, x equals -2. When we try x equals -2 and plug it into this inequality, we get 3 is less than or equal to 1. That's not true, is it? So that means that all values in between -4 and -2/3 do not work. Now let's try a value that is greater than -2/3. Let's try 0. Plugging 0 back into this, you get 1 is less than or equal to 3. And we actually solve for that up here. So you have 1 is less than or equal to 3. That's true, so it works. That means all values greater than -2/3 works. Now we have one last case where we have all values less than -4. So let's try -5. When we plug -5 back into this equation, we have 6 is less than or equal to 7. That works. So there's a check mark here on your number line. So that means, looking at this, all values in between -4 and -2/3 will not work. But all values greater than -2/3 or less than -4 will work. So then your final answer is x is greater than or equal to -2/3, or x is less than or equal to -4. And that is your final answer.